Okay, so we're recording. If you don't be on the video, it's going to be posted to YouTube, don't speak. We saw this slide on Tuesday, and this slide is certainly something you don't need to understand, at least all the details on the slide. This is from VTK, and it shows the abstractions that VTK has for doing rendering. And there was some notion of what we would build and what we would borrow. And so from VTK, we're borrowing all of this stuff in terms of windowing and interactors. When I click that it does something. And actually a renderer in VTK is the region where you can draw something. And then we're going to replace these, and in fact probably just this one, the mapper, with our OpenGL code in project 2A. The reason I say these plural is in the past, when some people want to write their own OpenGL code for the final project, they actually just take this harness and keep going with it. And so in those cases, in terms past, I've actually had a little lecture, mini lecture, about how to modify this stuff and so you can do more and more custom programs. So here's what we're going to do. Oh, you don't have a picture of me. I'm sure all of you watching at home are so disappointed not to see me. There I am. Hi. It's due February 21st. Of course, it's critical that you do some work on this during week 6, that you advance on both 1F and 2A in week 6. Of course, they're parallel projects, so if you get stuck on one, you can go on the other. There's a new code skeleton, project 2A, so we're not building anymore. That's why it's project 2 instead of project 1. And again, it's based on VTK, and the goal is to make this picture right here. So the picture on the left does the color scheme that we learned at the beginning, and the picture on the right does it with textures, right? So that's why we've been talking about textures. And so if you look very closely at these two pictures, and I couldn't see it on this image, but as you zoom in, you can see there's some spots where there's weird color interpolations on the left that you won't get on the right with textures. So let's just walk the code really quick. So it's actually quite a large starting point with a bunch of code that you don't want to know. I guess it's either good that I've written all this code that you don't need to know about, or it's bad that there's so much code that you feel like you don't understand, but it is what it is. There's a triangle class with an X, Y, and Z, and a field value. So again, we're following on to this visualization use case where there's a field value at every vertex. And again, a normal. There's a get triangles routine, which I think is the exact same get triangles that you're using for 1E and 1F. It doesn't have the if-def normals that you needed for 1F because you need them now. And so this is a function called getColorMap, and getColorMap will create a texture for you. And so this is 200, it will create a texture with 256 colors. And you don't really need to know that I'm starting with 8 colors, but I am. And so I'm starting with these 8 colors, and then I interpolate. If there's 256 colors, and I'm starting with 8 peg points, well then there's seven regions within the 8 peg points. Let me just draw this. So I'm starting with these these 7 colors, and then I'm interpolating texture values in between to, I don't know, this would be T. If there's 256 divided by 7, sounds like about 40 to me. I don't know, maybe 38. So I'm interpolating 256 texture colors from these 8 peg points above. And you actually don't need to understand this. I'm doing this, and then I'm returning for you this array of unsigned characters, 256 times 3. So that gives you the value for, or sorry, the color, the texture colors, and then as you have these field values, you're supposed to map them to the colors. I'm going to jump down to main right now. So this is all VTK stuff, and you actually don't need to go into main and do anything. It's using all this infrastructure for renders and render windows, and we actually looked at this before where we set up the camera. That's where we were before, and then eventually we get this so-called interactor, and we just say start, and once we say start, it will, well, there's a call above that actually brings up the window, but it starts it being an interactive process where when you click, it will take that click event and update the camera, and then it will ask you to draw. And the way that you're going to draw is up here, that there's a VTK441 mapper, and there's some tricks there about lighting that we'll talk about, and we'll talk about lighting, but right here, this is your call, and I've put in this thing that does 3 vertices. There's no colors or anything. So you're going to have to get the triangles and issue the correct GL calls. Again, there's 2 windows, so we saw this before. One on the left and one on the right, and the one on the left should be regular colors, and the one on the right should be textures, or I guess the one on the left is not textures, the one on the right is textures. And there's actually a class for each of these. So there's one that's called VTK441 Mapper Part 1. That goes on the left, just in the way that I've set things up. And there's another one called VTK441 Mapper Part 2, and that goes on the right, just on the way I've set things up. Okay, and if you look down here, you know, here's the one 441 mapper, and here's the 441 mapper part 1 and 441 mapper part 2, and they're added to different, in VTK the construct is renderers, and the one that has mapper part 1 is set so it gets the left half of the screen from 0 to 0.5, so 0 to 1 is the whole width, 0 to 0.5 is the left half, and then 0.5 to 1 is the right half. So VTK441 mapper part 2 gets in the right half. Okay, so this is a little orientation on the rest of the code if you want it. Really what it comes down to is there's this get triangles routine, which returns the triangles. There's this get color map, which returns this color map that you need, and then you re-implement render piece for both VTK441 mapper part 1, which will do the left half, and VTK441 mapper part 2, which does the right half. Good? Yeah, David?
So we're going to be like recreating our code basically from the previous project.
It's going to be super depressing, right? Because you're going to do it, and it will take not so long, and it will be way faster than your code, and there's, yeah. So, but you're going to understand what's happening underneath the covers. But you bet, it's going to end up being a lot like what you did in Project 1F.
Which is some OpenGL kind of like.
But you're, you know, so this is learning OpenGL, but the output is the same. So in 2B, we'll do something different. But in 2A, we're going to be using OpenGL to accomplish the same thing. Some hints. So, you know, I've said this, you know, throughout the term. You know, you never want to write more than 10 lines of code before you compile and run. OpenGL is super punishing. So it's a state machine. You set state, it remembers, you do stuff, and what it does is based on what it got before as the state. You say, I want to do this lighting stuff. It says, great, I remember. Say, I want to treat the triangles with these so-called materials. We haven't talked about materials. It says, great, I remember. And then you go and you render, you say, here are my vertices for this triangle, and it remembers everything you told it to do. And so what will happen is you set up some stuff and it works, and then you go try to set up something else, and it remembers the state that it got before. And I just really encourage you just to write just a couple lines of code and compile it and run it and see how it works, and make a bunch of backups. right? Here's something that worked, because it's a very common experience to this project to have something that works, and then you add something, and then nothing works. And so if you have something that you're like, I'm on the path to success, make a copy of it, right? Whether, if you're like super into Git and you want to push it to a repo, great. If you just want to make for me, my backups are like really simple. Maybe I shouldn't admit this like on a video I'm posting to the internet, but if I have something I like, I'll just do this. Whoops.
Print it. Yes. Print it.
Yeah, I'll print it, yes. Works pretty good, right? I make files like this all the time. And then when something doesn't work, I difference them and I try to understand exactly the lines of code I wrote. And I try to isolate the one line of code that did me wrong. That sort of stuff where you're making frequent backups will be really helpful this project. So it's not a lot of code that you're writing, but it's hard-earned code. Okay, so, and this is what I said before, OpenGL does state thrashing. It's common and it's tricky to debug. I would definitely say I would get one window to work perfectly. Go to VTK441 mapper part 1, make it work perfectly, and then go to that render piece method and make the first line of code be return. So you can take it out, and then go make the other one work perfectly. And then go back to the first one and remove the return command and have them try to work together. Okay, but don't try to sit down with a notebook and work out every piece of what you want to do and implement it and run it, because that approach can work for some things, but I don't think it works here. Make many backups of your program, and again, we had our big discussion on Tuesday, and my apology, and VTK6, and so use VTK6, and again, it's in room 100, and I did document all the stuff we had talked about on Piazza: fourth late pass, donuts, extra credit, etc. So how do you do colors? Traditionally, and this is the thing on the left, there's now a field value data member which ranges between 0 and 1, and you're going to use this get color map function, and if you have a field value of 0, you should give it the very first color. In this case, really I mean the 0th color, depending on how closely you read zero indexing stuff into English statements. Right, the 0th color, and a field value of 1 should be mapped to the 255th color, and then each field value in between should be mapped to the closest color. So you don't need to interpolate colors. If you have a field value of 0.4, and there are 255 colors. I don't know, what's 0.4 times 255? That's a bad example. It's 102.0, I think. I don't know, probably my math is wrong here, but I think that's right. So if that's the case, you don't need to go and say, what is the color for 104? What is the color for 105? And then somehow interpolate between 104 and 105, which you're all very capable of doing after our lerping. You can just pick the closest color and just use the color for 105 for that location. Okay? Any questions on 2A? Yeah, Linshu?
You mean the closest one? If that means if it's over 0.5, it goes to the up.
Yeah, what did I write? Let's see exactly what I wrote. It does say the closest. So let me answer your question in a somewhat indirect way. We no longer have a differencer program. It is not the case that you can go and run differencer and say, I got the right image because the images are the same. I have never actually checked to see if it's the closest, to see if you picked 104 or 105, if this is 104.55. I think some years, half the group will put 104, just kind of round down, and half the group will do 105. The images look darn close. So in this case, we're now going to the eyeball test, And even if I said closest, if it passes the eyeball test, I'm happy. One of the reasons we need to do that is because each GPU actually implements things slightly differently. So the images that come out of one GPU and another are not going to be matching. So there's all sorts of differences introduced in the rendering. So even if I said closest, that's not my intention to grade by looking for the closest. All I'm going to be grading for is, does it pass the eyeball test? And again, have you done the spirit of the project, right? I always have problems saying if you pass the eyeball test, you can get full credit, because someone could take a screenshot of my output and write a program that loads this screenshot onto the screen. That is not full credit, right? But if you've done the spirit of the project, you would get full credit. So, Lenshu, you asked a great question. The closest would mean you should round up, but I'm really not going to look for that. And then how do you do colors with the texture? It's the same idea, but use the texture infrastructure. So other questions about 2A? Okay. Palmer, did I see a hand? No, okay.